Good morning, girls. How are you? I hope you are all doing fine and all right. Okay, today we are starting in our new lesson, lesson 17.3, which is talking about rotations. As we said before, we have been talking from this beginning of the module 17 about the rigid motions. And we said that we have three main rigid motions. The first one was translation, which was moving your object up, down, right, left. And the second one was the reflection, in which we said that you were reflecting across a mirror, as we said before. And today we are talking about rotations. We said before rotation means as if you are looking on your ceiling fan. You remember when we talked about the example of a ceiling fan? In a ceiling fan, you have an object in between, which is the center of rotation. It's a fixed point. And then the ceiling fan itself is rotating in circular motion around this point, just like this shape, for example. Let me show you this shape. Just like this shape, for example. This is called rotation. This is called the rotation. In the rotation, you have a center of rotation, the point which is not moving in your rotation, and then all of the other points are moving in a circular motion around this point. So you have to understand something. For any rotation, for any example about rotation, there are three main important points that you need to know. The first point is where is the point of where is the center of my rotation point? Yeah, the first thing you have to identify is your center of rotation, which is the point that is not moving. It is the center. This is the fixed point. And then the second thing I need to find is what is my direction of rotation? Actually, we have two directions for rotation. It can be either this direction, which is against the clock. That's why we call it counterclockwise, or it can be the other direction, which is called the clockwise. And then the third thing you need to find is how many degrees should I rotate? In the example that you are seeing here, which is similar to the ceiling fan rotates 360 degrees because it keeps on rotating, keeps on rotating, keeps on rotating, just like the example we have in here. This is rotating, rotating, rotating with no end. So this is a 360-degree rotation. It keeps rotating. But for other examples, you can rotate with any degree you want. You can rotate by 180 degree, 90 degree, 70 degree, 270 degree, 360 degree. You can rotate by any degree you want. So you have to understand that for any rotation, always the three main points that you need to understand or to find. First of all, what is my center of rotation? I have to identify and understand where is my center of rotation, the fixed point that I was talking about. The second thing is the direction of my rotation. And we said how many direction we have? We have two. Either clockwise, this direction when you are moving with the clock, or the counterclockwise when you are moving against the clock. When you are moving against the clock. Okay? The third thing that you need to find is your degree of rotation. As I told you, these three things should be mentioned in any example. These three things should be mentioned in any example. Where is the point of rotation? It will be a point. He will tell you point P is the center, point C is the center, point whatever, the origin is the center. He should give you the direction of rotation, either you are moving clockwise or counterclockwise. He should give you the degree of rotation. He will give you in the example, it is 90, it is 70, it is 60, it is whatever. Okay, so these three main things should be mentioned in your example before you start solving or before you understand what's happening in your example. Okay, let's go back to our book. in page 857. Page 857. Okay, in number A, he is telling you draw a triangle. Suppose that we have triangle ABC, and this point P was the center of my rotation. So I understand the first thing, as we said, that this point P is not moving. This is the center. All the other 3 points of the triangle ABC will be moving and rotating around this point. I still need to know 2 things. The first thing is the direction and the degree. Okay, in here he didn't tell you the direction, but actually he gave you the image already. He told you that triangle ABC was rotated 90 degrees around point P. 90 degrees around point P. Take care. We can either rotate 90 degrees clockwise, so my triangle will be in here, or we can move counterclockwise, so my triangle will be in here like this image. To understand how did it move a 90 degree, to understand this, let's go to this shape and try to understand how can you do the rotation correctly. Let's suppose that we have this polygon, or this is not a quad. Okay, we have this figure. We have A, we have B, we have C, we have D, we have A, B, C, D, E. Yes, 5 points. And let's think about point F as the center of my rotation. Point F is the center of my rotation. And for example, just to be very, very easy, this center of rotation was the origin. The origin means it was 0 and 0. Okay? And then, just let me name this point. Okay. Let's try to move this object. But the first thing I understand now is that this point is the center of my rotation. Okay, this point is the center of my rotation. The example, for example, will tell you I will be moving counterclockwise. So I understand that counterclockwise means that this object will be moving in this direction. It will be rotating like this, not in this way. No, it's rotating counterclockwise. And let me tell you, for example, that it will be a 90 degree. Let's start rotating this object and see what will happen. Let's start rotating. Yes, I am rotating. Can you see? At angle 38 degree, this was the rotation. Let's complete rotating. Let's complete rotating. It's rotating around F, around the origin. It's rotating. We reached a 90 degree in here. Did you see it? This was the 90 degree. And then let's complete. It's still rotating around point F. It's rotating. It reached 180. Can you see the 180? The 180 as if it's like, yeah, as if it's like a reflection around y equal to negative x. As if. Okay, let's complete. Let's complete. It's still rotating. This is the 270 exactly. Did you see 270? Did you see it? And then what about 360? Before I go to 360, what do you think? At 360 degree exactly, what will happen to my figure and the image? They will be the what? They will be the same. Exactly. So I started from 0. I started rotating. At 90 degree, what happened? You remember when I told you before? I told you before, 90 degree means that your points are moving how many quads? 1 quad. Let's see. Point A, B, C, D, E, all of them was in quad 1. At 90 degree exactly, all of them went to quad 2. So this is very good. It's exactly as we said. At 90 degree, all the points should move 1 quad. Okay, let's see what about 180. What will happen at 180 exactly? At 180, yes, all of the points are they moved 2 quads. They were in here, and then they moved quad 1, and then they moved to quad 3 in here. So they moved actually 2 quads. What about if 270? What if I move to 270? How many quads they moved? 270 exactly means they moved 3 quads. Quad 1, quad 2, quad 3. What about 360? 360 means nothing happened. As we said before, your figure will go back to its place. So I understand now what is rotation. We understand what is rotation. According to our example inside your books, if we go to our examples to try to solve question C and D, he is telling you let's rotate it 90 degree counterclockwise. So let's do this to our object. Let's do this to our object. I know that the object that we have is not a triangle, but we can work with it. It's not a problem. So let's try to move our object in here 90 degree. Let's go back and move it and rotate it 90 degree exactly. Yes, this is the 90 degree exactly. This is the 90 degree exactly. Yes. Can you see your figure? This is my pre-image and this is my image. Okay, so my points rotated 90 degree counterclockwise. Okay, let's go back to our books and see what's required from us. In question C, he is telling you, draw angle APA prime and BBB prime and CPC prime and measure these angles. According to our example here, he means I have to draw the angle from APA prime. Yeah, I'm going to connect a line between this to formulate an angle. And then I have to do the same thing for B and B prime. And then I have to do the same thing for C and C prime. Which mean, let's go back to our example. A became A prime, right? By rotating around this point. Okay, let's connect, as he's saying, let's connect a line between this point and the center of rotation and A prime to formulate the angle. Okay, this is what I'm going to do. I'm going to draw a line from here till here, and then from here till here. What is this? This is angle APA prime. This is exactly the angle he was saying. APA prime. If you continue in your book, if you go back to your book, what is he saying in your book after drawing the angle? Measure these angles, and what do you notice? Well, does this relationship remain true as you move point P? What happens if you change size and shape of ABC? Yani he wants us to measure angle APA prime, BVP B prime, and CP C prime, which mean in our example, let's go back in here. Let's measure this angle and see. Before I measure it, طبعا measure an angle, which mean I'm going to use a what? A protractor. Before I measure it, I rotated how many degree? I rotated a 90 degree, right? Yani angle A moved 90 degree to reach in here. So before I measure it, I predict that this angle should be what? Should be 90 degree. Okay, let's take our protractor. This is my online protractor. You remember before we said to measure an angle, you are going to put the center on the center and then the line, the main line of your protractor on one of the two lines. I have two lines on the angle. I'm going to put it on this line, for example. I'm going to get my center, put the center on the center in here, and then the line on the line. Can you see the line on the line? And then I have to measure the angle, the reading of the angle from the second line. So let me, yes, to make it easier for you, this is easier. Now let's read. I have a 0 in here and then here. Which one should I read from? I always read from my line. So it's from here. يبقى 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. So this angle is exactly 90 degree. So I can say that, sorry. We can say that angle A prime is exactly 90 degree. What if you do this to another angle? E became E prime, right? What if we try to draw a line again from here till here? Sorry, I don't want this line. We want a segment. Yes, what if we try to formulate this angle. I'm drawing lines, girls, because I need to find the angle. Angle is a corner between two lines. That's why I'm drawing a line. You understand why? He is telling me to measure an angle. There is no angle because there is no line. That's why I'm drawing a line to formulate an angle. So I'm drawing line between E and the point of intersection, and then I'm going to do the same thing between the center of rotation and its image. And I'm going to try to measure this angle. Before I measure it, what do you think? It will be what? It will be 90 degrees because I rotated 90 degrees. Again, put the center on the center. The center on the center. And then put the line on the line. This is the line this time. Yes. And then, should I measure it from here or there? There is nothing. My line is in here, so I'm going to measure it from here. So 0, 10, 20, until I reach again 90 degrees. So this angle is 90 degrees. If I do the same thing for C and for D and for B, you think that the angle will always be what? Will always be a 90 degree. So you have to understand very well that the angle always between the angle always between the pre-image and the center of rotation and the image will always be the angle of rotation. They will always be constant for all points of your figure. So in question C here, for question C, when he was asking about draw angle whatever the angles that we draw and measure these angles, what do you note? All of them are what? All of them are equal, and they are equal to what? To the 90 degree that I rotated. All of them are equal to the angle of rotation. Does this relationship remain true as you move point P? Which mean, what if my center of rotation, let's go back in here. What if my center of rotation moved? What if my center of rotation moved? Yani instead of here, it became in any other points, for example. What if my center of rotation moved? Yani in here, for example. What will happen to the angles? So I'm playing with the center of rotation. I'm playing with the center of rotation. If the center of rotation moved, if point F, which is the center of rotation, started moving, let's remove all of these lines. And then let's move the center of rotation in here, for example. This is the center of rotation, the new center of rotation. Okay? Let's see. What if I try to measure the new angles? The center of rotation moved. Let's see. If I try to measure the new angles, will they remain equal or not? They should remain equal, and equal to what? 90 degrees. We will see. Let's see. Again, I'm going to draw segment from here to here, and then from here to here. And then let's take our protractor, put the center on the center. This time I'm going to measure it from this line. It's easier. Okay. And then, should I read it from here? No, there is nothing here. I should read it from here. So I'm going to take the 0 in between. I'm taking now the internal reading. 0, 10, 20, 30, 40, 50, until I reach exactly 90 degrees. So it is the same, equal to the angle of rotation. If I move the point of rotation, the angle of rotation will always be the same. Very well, understood? So we can write in here, for question C, we are going to write they are all equal to 90 degrees, which means they are equal to the angle of rotation, regardless, or even if the point of rotation moved. The other part of the question is, what if the size of the object change? The size of the object change, the size of the image will change, but the angles will remain what? The angles will remain the same. يبقى even if the point of rotation moved or the size changed. Okay? Okay. Let's go back to our books. Question D. Measure the distance from A to B and the distance from A prime to B. What do you know? He means what? He means, you remember our example in here? We don't need the protractor. Okay. What if I get a ruler, for example, and measure the distance from here to here and measure the distance from here to here? What do you think? We have boxes, by the way. We can try to measure it by boxes in here. We have box 1, 2, 3, 4, and 5. Yani it is crossing 5 boxes. It should be doing the same in here. Let's count. 1, 2, 3, 4, and 5 boxes. Again, it's crossing 5 boxes. And if we actually get a ruler, but I don't have a ruler in here. If we actually get a ruler and measure the distance from the image to the center of rotation and measure the distance from the pre-image and the center of rotation, they will always be what? They will always be the same. Take care. When you are rotating, the angles are the same between the image and the pre-image and the center of rotation, with the lengths are the same. And this length is equal to this length, and the angles are the same. Take care very, very, very well. So in question D, he is telling you that for rotating, this will always be equal to this. This will always be equal to this. Very, very important note. So in question D, we are going to tell him that the distance are equal even if point P moved or size changed. Okay? Okay. Let's go back to our book. Question 1, reflect. What can you conclude about the distance of a point and its image from the center of rotation? The distance are always what? The distance from a point and its image from the center of rotation are always equal or are always the same. So in question 1, you are going to tell him that they are always equal. The distance is equal. We can write this in here as well. Question 1, the distance are equal. Okay, going back to our book. Okay, you remember when we were taking translation and reflection, and I told you that each time to do reflection or translation, we did it in 2 types or in 2 ways. The first way was using the ruler or using the geometry way. The second way was using the rules and the coordinate notation way, right? The same thing is happening in rotation. The first way, which is explain 1, will be using the geometry way. Rotating figures using a ruler and a protractor. We need to have both now. You need to have your ruler and your protractor. Rotation depends 100% on protractor and rulers. So please try to prepare them for now. And then tomorrow, inshallah, we will be taking the second way, which is the way that I know most of you will love, which is the coordinate way, which is depending on some rules that you are going to know by heart. But first, let's investigate the first way, which is the geometry way, using a ruler and a protractor. A rotation is a transformation around a point, which is called the center of rotation, so that every point and its image are the same distance, as we have explained, where all the angles are equal, they have the same measure, and this angle is equal to what? To the angle of rotation. That's why I told you, when he gives you an example like this, the first thing you have to understand, or the first 3 things you have to find, as we said, where is my center of rotation? What is my angle of rotation? Where is the direction? Where I am rotating? Okay, let's see this example. In question A, draw the image of the triangle after the given rotation. I have a triangle, as you can see, ABC. Counterclockwise, the first thing, he gave you the direction. I should be moving counter, not clockwise, no counter. I'm moving in this way. Counterclockwise rotation of 150 degree around point P. He gave me the angle is 150, and then he gave me the point that I'm going to be rotating about, which is point P. It's going to be point P. Okay? Okay. Counterclockwise again means the direction is in this way, as he's telling you in here. I am moving in this way. Okay, the first thing that you have to know, step one, and we have to do, is I'm going to be rotating a point by point. I'm going to be rotating point A, then point B, then point C. We are going to be going through these two rules that we have said, that every point and its image are the same, and then all of them are rotating the same angle. So the first thing you have to do, ya banat, is to make sure that the image and the pre-image will be the same distance from P. How can I do this? First of all, you will draw PA. Yani I'm going to rotate point A first. So I have to draw a line from P to A. I picked point A first, that I'm going to draw to rotate point A first. So I'm going to get my ruler, go get your ruler, and then draw a line from A to P. Okay, we draw a line from A to P. Okay, the first step is done. And then I'm going to go get my ruler, my protractor, sorry, and put the center on the center. So, and where is the center? The center of your protractor is put at the center of my rotation, which is point P. And then the line is on the line. Since I was talking about a counterclockwise, take care, there is a main important thing in here that you have to understand. Okay, so as we said till now, the first step that I did was connecting the center of rotation to my point of rotation, to the point I want to rotate. And then the thing that I was telling you about, girls, the protractor can either be put in this way or it can be put upside down. And this 90 can either be up here, or while you are working, you can put it to the other side. Should I put it in here, in this side, and it should be facing upward, or should I put it facing downward? It's according to the direction of my rotation. The direction of your rotation is what? Counterclockwise. So I need to be moving in this way, which means my triangle should be here somewhere. Since it should be here somewhere, you will be understanding, should I put my protractor here or upside down? Girls, if I put it upside down, if this protractor, instead of looking here up, it was looking down in here. So my triangle will land where? It will land here. But my triangle rotated from here to here. Is this a counterclockwise? No, this will be a clockwise. That's why, by understanding, the protractor will always have two ways, either facing upward or facing downward. How can I know, should I put it upward or downward? Based on the direction. The direction here is counterclockwise. So I should move in here. Yani I should be facing in here. Yani I should be reading the degree from here. That's why I put the protractor in this way, not in the other way, and put it facing downward. Okay? Okay. I put the center on the center, the line on the line, and then I will start reading. Of course, I will read from the inner or the outer? From the inner. Always read from the smaller one. And I should read how many degree? 150 degree. 0, 10, until I reach 150 degree. So the 150 is in here. And then I will put a point. I will mark a point at the 150. And then what should I do? I will get my ruler and draw a line. So now we have two lines. I have PA and I have another line. This another line have the point A prime in somewhere. Where is the somewhere? Didn't we say from a minute that always the pre-image and the image will lie in the same distance, right? So what you are going to do is that you are going to get your ruler and measure this distance carefully. For example, PA was 3 centimeters. And then you will go and get your ruler and measure 3 centimeters on the other line that you did, and then you will find A prime. And then you will find A prime. Yani I mean, for example, this was point P, and this was the A prime or the point A. Okay, and this was the first line that you did. طبعا you have to use your ruler. And then after using my protractor, I draw a big line in here. I don't know where is A prime exactly. Is it here? Is it here? Is it here? Is it here? I don't know. To find where is A prime exactly, I'm going to go get my ruler and measure this distance carefully. For example, this is 3 centimeters. This was 3, for example. So I'm going to go and get my ruler and starting from here, measure up 3 centimeters. For example, 3 centimeters is in here. So this will be A prime. I found A prime, and I have to remove all of the other part in here. Okay, let's go back to our book. What are you going to do? You are going to do the same thing. You are going to do the same thing for the other points. Remember, we have how many points to rotate? I have 3 points. I only did A till now. I have to do the same thing for B. What I'm going to do again, I'm going to draw a line from B to P. And then I have to put the center on the center and measure 150-degree upward again. And then I will measure this distance and measure the up distance until I find B prime. And then I will do the same thing for C until I find C prime. And then I will close my triangle. It will be A prime, B prime, and C prime. Okay? I hope it's a little bit cleared out. I hope it's a little bit cleared out. Okay, anyway, I will be putting a video for you on HRW, Professor Berger, explaining this part again with more details. And I will do question B with you tomorrow, inshallah. For you as a classwork today, you are supposed to try to do question B and try to do question 4 and 5 as well. 4 and 5 as well. Okay, just as a hint for you about question B. I have in question B triangle DEF and point Q. And I'm rotating around point Q, so I know that Q is the center of rotation. I know that I'm rotating clockwise, and I know that I have to rotate 75 degrees. Okay, the first thing that I'm going to do is that I'm going to draw a line, for example, from D till Q. And I have to draw a line. Just, I have to draw, sorry. Okay. Yes. The first thing that you need to do will be that you are going to draw a line from here till here. For example, right? From D till Q. Before you put your protractor, because this was the main issue, should I put the protractor up in here and it will be facing here? Or should I put it in the other side? I want to do it with another color if I can. Or should it be facing the other side in here? Should I use it upward or downward? For this kind of question, ask yourself. Here he is asking you to rotate clock or counter. Clockwise, right? Clockwise means that my triangle will rotate in this direction. So it will land in here. But how can I put my protractor up here and all my findings will be up? You understand this part? This part is very, very, very main important thing. The protractor, girls, can be put either upward or downward. Where should I face it, upward or downward? Ask yourself. My triangle is moving clockwise, so it will land in a place in here. It will be moving in here, in this direction, and it will land in here. If I put my protractor up here, all my findings will be up there. But this is not a clockwise, this is a counterclockwise. So instead of facing it in here, no, I'm not going to be using this direction. All of this is no. I'm going to be using the other side. But it's going to be put in here. The center on the center, the line is here, and then I have to measure a 75-degree and put my line. You understand? And then I have to get the ruler, measure the distance, again measure the same distance and put the point. And then do the same thing for E and do the same thing for F. Okay, I hope this cleared out a little bit of the confusion. Please try to complete number B, try to do number 4 and 5, and send me pics of your answers. Thank you very, very much, and hope you understand.